Got two presentations for you today. Um, they're both kind of on the theme of injection molding. It's kind of annoying, there's a green overlay. Well, you'll deal. Um, so they both kind of circle around injection molding within and both design, which is more what I'm going to focus on, and she'll be talking about kind of using the mold flow analysis. Um, and we'll hopefully not overlap too much on some details, so you don't hear the same thing twice. But we wanted to go through some more of the design tools, just kind of a quick overview, and then let her take over. Cool. Um, also, Connor went ahead and put this presentation together, but unfortunately wasn't able to present it himself, so I'll be presenting. But yeah. So a quick overview on just what is injection molding. For those not familiar, essentially it's a two, although sometimes more, but basic overview. You have two halves of mold, a core and a cavity, often steel, but can be aluminum and other things, that you're injecting molten plastic into essentially to create a the empty space between the two parts, between the two molds, the core and the cavity, it becomes your part essentially. Um, this is used for high volume manufacturing typically. It can be highly accurate and pretty cost effective way of manufacturing. But again, when you need those high volumes, anybody who's dealt with this also knows mold costs can be quite expensive. So, you got to have your reason to invest, 10, 20K, maybe 100K, depending on your part and the type of tool you're doing. So you want to be running a lot of parts. But that's kind of a quick overview. Um, there's some different constraints with injection molding that you have to consider when designing. Just like with any type of manufacturing, right? There's trade-offs, there's different types of things to consider. With injection molding, there's a few things. Materials pretty important to know. I mean, one, you're dealing mostly in plastics. There is metal injection molding, but we're not going to really touch on that too much. But you're dealing with plastics, but knowing what type of plastic, so that way you know what type of wall thicknesses and stuff you can get away with. To touch on the other thing, wall thickness is maybe the most important thing when considering injection molding. Understanding what your wall thickness can be and being consistent with your wall thickness. Getting that using draft in general. So because you've got your two metal mold pieces, you have to get your part out of the mold. So that's where your draft comes in. So you can actually get your part out of the mold after it's injected. Keeping in mind where your parting line is, which is essentially the line that separates your one half from the other, your core and your cavity. It's essentially the meeting line of that on the part. Keeping in mind things like radii, fillets, bosses and gussets, just different ways that lots of these are all things we're going to touch on a little bit in more detail, but the way you need to integrate in ribs and everything is important. There's some more advanced features that we're not going to touch on too much in this or really probably at all, but just to give you a quick highlight, things you want to avoid is undercuts. So features that have to be, you think of if just to try and define an undercut, if you're not familiar, like if you have no way to get to the underside of something from the top face, that's going to be a very difficult feature to mold. It can be done depending on what it is, but there's also a lot of ways it can't be done depending on how you design it. So avoiding it altogether is typically recommended. Snap features, I mean, threads and texture and text, all things that are possible, but just a more advanced feature. So yeah, as I was saying, one of the most important things with molding is wall thickness, and specifically consistent wall thickness. So typically you're going to select um, your nominal wall thickness based on your material and your material properties, and also like what type of strength and everything you're trying to get from that, right? So whether you're doing like ABS or polyethylene, you might go a little thicker or thinner on the wall thickness. But once you've established that, that's where you want to stay consistent. So you can see here on this cross section, and I'll pull up the actual model here in a minute too when we're talking about a few things. But we have a very consistent wall thickness. You want matching radii, which I'll touch on. Um, and the places where you'll see the thickness change are for good reasons as well. Things like these ribs. Um, so and actually, yeah, sorry, no, we do touch on this in this slide. So things like ribs, there's rules of like a half thickness of your nominal thickness, right? Because you have this big mass of material where um, overlapping on material to prevent things like sink on your part. You want to have like a half your material thickness rule, and then you have your draft from there. Um, so these are kind of a little, you know, quick rule of thumb for some different stuff for internal radii, external radii, ribs, all that here that we kind of use internally, and are kind of generally good rules. But you can definitely there's a lot of best practices with injection molding, and then there's a lot of cheating a little bit here and there. So you can get away with certain things, but you can't get away everywhere all the time. You have to pick your things, pick your battles. Hey, this feature is not ideal to make, but it really needs to be like this, and it's hard to do it any other way. Then it's like, okay, well, maybe you can cheat that one feature, but you don't want to cheat every feature on every part. I mean, it just becomes too difficult to mold at that certain point. Let's actually go to the model for a second. As soon as I guess I have to exit this for it to work properly. Come on. There it goes. Okay. Um, so one of your best friends when designing for molding is the shell feature, which if you haven't used, looks a lot like this. So you've got your block that you've designed. Essentially, this is your part, but you've got all this extra material inside. You can't mold it like this. Can't be solid like this. Not really practical. Um, let alone possible for mold flow analysis from a mold flow standpoint. So we can talk more on that. But so what you've got to do is get that to a consistent wall thickness. So use the shell. Simple as that. We already, now when we were designing this, we built the draft into the boss extrudes. I'll touch on that for a second. Sorry, my scale is like way off because I was on my other monitor before. So I'm sorry, that was really small. Not entirely sure I can easily fix that. Oh dear.
Tell us what the draft is.
Yeah, yeah. So with the bosses, yeah, I think everything's at a 2-degree draft for reference. But yeah, so we're designing in this case with the draft in there. A lot of times I also like putting drafts as separate features because it makes it a little bit easier to see from the feature tree where it's doing that. Now, this is a very simple part, and this is just kind of how they decided to do it. But it's certainly a thing. And there are some external drafts, and the reason for that, actually, if I scroll up here for a second. So as they were creating the part, you'll get features like this because we built in the draft as they were building, where this is now essentially an undercut, which I'll touch on in a second, because we'll use we can use the draft analysis, or maybe I should just so small on my screen too. You can see even from here, and we have a slide talking about it as well, but I'll just touch on it now. So we're getting that undercut there in our direction of pull because the way it was modeled with the draft extruding up. So later, that's reverted with a secondary draft after the fact, and then uh, we can do the shell. The other thing that's nice to do before the shell are any fillets that you can that make sense to do. It saves a lot of time because now rather than worrying about your fillets after the fact and making sure you have a consistent wall thickness, because I have these fillets here, when I shell it, I'll already have my matching radii. I don't have to think about it. But there are places where sometimes it's just not practical to fillet it beforehand, so you just have to know to go back, afterwards. Sometimes you'll get some weird geometry that just, you need to attack later. Yeah, that's mostly, I guess, as far as the wall thickness. I think that covers what I was talking about on this slide. I guess we do have we can touch on ribs and stuff. Sorry, let me go back. I clicked the wrong one. There we go. So the other thing we use here, so small. Okay. Is the rib feature to create some ribs here. So when you're designing for injection molding, right, we can't have a solid part that's just a big block of plastic, but you do still need structural rigidity, right, often with parts. So the way you accomplish that with injection molding is by ribbing it in such a way where you still have that rigidity while not, just a solid block of plastic, right? A solid block of material. If I was to CNC this would be a huge waste of time, right? I would just leave it solid. If weight and all types of other things aren't being considered, then no reason to cut all that extra material. That's just machine time. But for injection molding, it's the opposite, right? It's much more efficient to not have that material included. So anyway, we put in the rib tool where you have things like multiple ribs coming together. You just have to be careful. So a junction like this where you have three is not really an issue. But when you have junctions like this, a four away, what you end up is having a lot of material building up there. And so what you'll often get on this side of the part is sink because that material is cooling and kind of settling down into the part. So if you want a better cosmetic finish, and it can also affect things like flow, which you can touch on, but what you may want to do is add features like this boss, where instead of the ribs all coming together in one spot, you actually have essentially junctions like this on all four corners instead of all together. So just trying to, be smart about how you're ribbing things, looking at your cross sections to make sure you've got good, consistent wall thicknesses, that your taper for your ribs is correct, that you're tapering down, not up. And then that's also where your next stage, when you've done all that, you want to do things like draft analysis to see where you screwed up. Because I'm sure we've never done that. There we go. So I think in this case, I'm supposed to have 2 degrees. So with 2 degrees, everything is green with the part the way it is right now because we fixed that one issue. But that issue I was showing you before, that was that separate draft feature. If I just suppress that real quick, it'll live update. See how that's showing red and yellow because these features won't be manufacturable with the parting line I want, where this is the core and cavity of the part, and the parting line would be this, essentially this outer edge here, this outer edge all the way around. But that's not going to be possible. Now, maybe it's really critical that face be like that. I need to change, certain things about the mold and make things everyone's life a lot more complicated, or negotiate and add that feature back in, and now we're all green again. And then as you saw, obviously it pulled in things where, let me do that one more time actually. This is definitely beyond, and then this is right on the line where it's like, well, you can't, so you'll see the kind of color spectrum to kind of give you an idea of what you can and can't do and what's right on the edge and maybe not possible versus, yeah, okay, that's definitely fine. Let's see. Kind of touched on a lot of that stuff. Yeah, we did talk a little bit about how our draft is currently set to 2 degrees based on our part geometry. That seemed appropriate for this, assuming we're going with a smooth finish. But something when you need to consider is depending on the finish you're looking for, you may want 3, 4, 5 degrees of draft. So depending on how aggressive your texture is, 1 degree of draft per 1 thou of texture. So if you've got a very textured part, that's going to have a lot more draft. 1 to 2 degree draft is typically acceptable. I've seen really critical parts where they needed it. They can get 1/2 degree of draft if you're working with the right molder. What ultimately it comes down to is typically your part price is going up because their throughput is going to be slower. They got to be more careful taking it off mold. It's just in general, it's going to be more of a pain. Maybe they're going to have to run, extra push pins to get it out of the mold, things like that. So you can go really low on the draft in some cases, but again, it's comes down to like, what are you optimizing for price, kind of trying to design for manufacturing in mind. Often something like 1 to 2 degrees, 3 degrees. Certainly a lot of molders will love you if you can give them 3 degrees on everything and it's a smooth texture. But yeah, one thing that's not noted here that's maybe an exception, if you're doing something that's like a true hole, particularly if it's not a deep hole, but even deep holes, often you can get away with 0 draft. They're just able to do those with like pull pins. And so if you have something where you need a straight bore hole, those can actually be often done with 0 draft with all the features around it. But you do still have to be careful because if your bosses have draft, but your hole doesn't, your wall thickness goes back to the wall thickness problem, right? So then you can end up with the wall thickness getting too thick and, maybe having sink issues and other things. So, and just to touch on what I mean here real quick, turn off the draft analysis. Is this hole, if we didn't want draft in that hole, we could get away without it, likely. The molder could likely do that without draft if we needed it to be. But whereas all the other features around it, they would want draft.
So on that,
yeah.
For all of that,
yeah.
Is that drafted opposite of the outward draft?
No, he doesn't have any draft at all.
I think currently the way this was designed, it actually doesn't have draft on it, right? I actually don't know. It does. No, I think actually it does. Yeah. So he's got draft on that. So yeah, that's drafted inward on that hole. But you could get away without, you could put 0 draft on it. Yeah. Yeah, this is currently giving me a thicker base, but our rib thickness was already at half our material thickness. So it's unlikely to give us much issue.
Okay.
But that is where you could have that, you're getting more material though. If I did want to go to a straight bore, let's say I'm using that like a screw boss and I want that to be a straight bore. Well, all that extra material is now there because the draft's gone, right? And then you start getting a little bit more on the questionable side. Maybe I go to like 1/3 material thickness just to try and, in that area specifically. So start playing with those features. Yeah, I think I kind of touched on all the, yeah, that's the other slide. Touched on all the kind of critical things we were gonna, there's a million more, that's maybe slightly exaggerating, dozens more, Molding tools that we didn't touch on. Maybe we'll do this in a future presentation. I was looking to kind of cover some basics this time, kind of give you an idea of some different tools and how to use them, and some design for injection molding tips. But any questions I can answer though? Oh, yes, Jim.
So, the one thing I didn't hear you talk about at all was your, injection ports. Where would you plan on injecting that?
That's a good question. I would say
You use
Yeah.
more than one, or would you?
I will have to, I would
okay.
have to let her decide.
Okay.
I would say from my perspective, I'm gonna play the dummy who doesn't know.
Okay,
And-
and the only reason I
No, no,
mentioned
good.
that, I just watched a video
Yeah.
where they were doing an injected molded part that was a lens, and because of the way the features were, it left a line where the flow.
The flow line,
together.
yeah, okay. Yeah, I'm sure that may be something she'll touch on. Yes, that is something you often do want to consider. I will play the dumb designer who doesn't know, but tried to follow all the rules. But yeah, absolutely. Number of ports you might, so especially if there is an area like on a lens, if you're trying to have like a clear feature or something like optic area,
Right,
flow can definitely be a major concern there, and you would want to call it out on your drawing that ejector port, ejector pin, and injection points can't be in certain areas so that they avoid the area you're trying to keep clean, basically.
Right.
Yeah. I think an example of that is we were doing some tooling for Dexcom actually, and we have some of the people here, that's why I point. There are some critical surfaces that for optics and other reasons function that it was like, hey, you can't put injection pins on these faces, even though from a molding standpoint, they absolutely would have wanted, if you didn't tell them, they would have put ejector pin spaces.
right.
But you have to point to them and go, no go area, anywhere around that area. So,
Do you use the draft analysis tool to see if your ribs are effective against sink?
no, that's really that would be more of the mold flow analysis will show you. I think. I mean, you correct me if I'm wrong, but the mold flow analysis will give you an idea of like areas you might have sink or not. Right? Yeah, she's much more familiar with it than I am. So that's just yeah. It's kind of like a sim tool. Yeah, so it's a extra bonus.
Is it not necessary to put a fillet on the ribs, like at the bottom of the ribs?
Oh, that's a good question. It's not. No, you don't have to. Yeah, and actually sorry, what was that?
Right of the plastic flow in the pool.
Oh, sorry. Go ahead.
Plastic flow there.
Gotcha. Yes. So you may want to, but you can get away with it. But the other thing, there are a couple things you may consider, and I don't know if the mold flow touches on this, but also life of tool. If you've got hard edges, inevitably your edge on your mold will wear. So you may want to plan a radius, but also the other thing to consider, which is kind of an interesting thing. I think we've touched on it on another presentation before, but when you're designing for injection molding, you have to kind of think of it backwards if you want to think about the mold also in terms of designing for manufacturing of the CNC in the mold, because sometimes you'll add a feature to the injection molded part that seems perfectly reasonable, but it's a pain in the butt to machine on the actual tool because it's the inverse, right? You have the inverse geometry on your tool, and it may be a feature that's very hard to machine that looks simple on this side, but isn't, right? So like a radius or so a radius on this side is a boss on the other, basically, or it's the opposite side. But there may be areas where you add basically you get kind of like depending on also where your parting line is, you could have a radius into like an infinite sharp. If you think, oh, I'll just put the radius there, but then your parting line's right there, well, then you have a radius up to your parting line. That would be a bad design for for manufacturing feature, because now you've got that really sharp, infinite sharp point on your mold. So not in this case in those areas, but in other places you might end up with that. So speaking of which, actually, no, so he didn't do that on this because he knew where his parting line was. But if I didn't, what I'm getting at there, so if I, oh, sorry, I didn't click the face. That's what I'm not seeing. So what I'm getting at is like this face here is a sharp because it's my parting line. But if I did add a fillet on this edge, just do that a little differently. Sure. So now it'll create a weird situation where if one part of the mold has to have that, then it's like an infinite sharp on the tool. And anyway.
Well, the tool maker would have to split that in the center of that wall. and
Yeah.
have half the side, half on the other side.
Yeah.
And you put the fillets on both sides.
Yeah. And then it will never really look perfect, and it'll, it might look pretty good, but ideally you want something like this. It's a much easier parting line. Yeah, any other questions? You want to get to the other cooler presentation? I get it. All right, cool. I appreciate it, guys.